Good evening, everybody. Today is day 13 of Math 133. We're going to cover the chapter 6 review. We're going to talk about the sample midterm, and we'll talk a little bit about the midterm, but this is the last class before the midterm. Um, and it's almost spring break too, so that's also exciting. Um, chapter 6 review is going to happen on page 408 in your course pack. Um, and chapter 6 is on the midterm, so we'll cover that today. And then we'll do some more of the sample midterm. The sample midterm is due on Thursday. Anything I don't cover today, Cindy and Elaine will work on with you tomorrow. Yeah. And then there's no lecture notes due right now. So use the time that you normally would have to, catch up on any missing worksheets that you have and also study for the exam. Um, on Thursday, you can see that there are a whole bunch of lecture notes that are assigned that are due on March 10th. So once you've taken your midterm, you'll want to start watching the lecture notes for chapter 7. Okay. Yes, you can start watching those now, but chapter 7 is not on the midterm right now. You probably want to focus on studying, right? So for the midterm, you could have taken it today. Is, is anyone joining us who's already done? You could have taken it today at the testing center. You can take it tomorrow. Oh, Rachel did. Nice. Well done. So we're going to cover the chapter 6 stuff, but Rachel's like, I already got this chapter 6 stuff. I'm good. So, we're going to cover chapter 6 stuff today. Oh, Crystal did also. You guys are on top of it. And then uh, if you want to take it at the testing center, you can take it tomorrow. You can also take it on Thursday or Friday. If you're taking it with me on Zoom, we will meet on Thursday in the morning from 9 a.m. till noon. Or if you want to take it with me on Zoom in the evening, we will start at 6 p.m. and go until 9 p.m. Okay, so normally we start at 6:30. If you join at 6:30, I mean you can. It's just you're gonna be 30 minutes late, so don't do that. Uh okay. And I think that's all of the announcements. Um sample midterm and, and yeah, I don't think I'm I think I'm good. I think I'm um oh, that's what it was. There's no attendance this week. There's no that thank you for reminding me that. If you miss class today and you miss class on Thursday, I mean Thursday's the test, that's okay. There's no participation point. So you don't have to join today. I mean, you probably want to join today so you can see how to do the chapter 6 review worksheet. But if you're watching this on the recording, then you do not have a discussion board that you need to go fill out. Okay. So thank you for reminding me on that. So yeah, if you take it at the testing center, then if you take it at the testing center, this is the last day I'm going to see you until March 10th. So if you take it at the testing center, I'm not going to see you on Thursday. So yeah, have a good spring break. Okay, so there's all the announcements. Uh, no discussion board this week. Lecture notes are going to be restarting, and uh, make sure you get everything turned in. Um, you know, if you're behind on your worksheets and stuff, like that's okay. It's just, doing these worksheets is one of the best ways to study for the exam. So, you really want to be caught up before you try to take it. Okay, so let's jump into page 408. Uh, yeah, so the chapter 6 review is part of your worksheet grades. So worksheets make up 10% of your grade. Yeah. Um, we're gonna go through here and give you some hints. The discrete probability distribution shows the number of major cities, over 250,000 people per state in the US. Explain what must be true in order for this to be a valid probability model. So they told us it's a discrete probability distribution. So the answer is not because they told us, okay? In order for you to have a valid probability distribution, there's two, well, technically three parts to it. Yep, so Rachel says that all probabilities have to add up to one. Now, I'm a mathematician, which means I'm lazy, so I'm gonna write it like this. This is a capital sigma. Sigma is the Greek letter for S, S for sum. So I'm summing, I'm adding all the probabilities up, and if you add all these up, you should get 100%. Now, you don't need to actually add them, okay? You just have to say that that must be true. If you want to write it out in words, you can. The probabilities, if you're not lazy like me, sum up to one, okay? Yeah. So we've seen lowercase sigma before. Lowercase sigma is the lowercase Greek letter for S, which is for the standard deviation. So, and the other one, yep, Gabby's got it. So probabilities are always between 0 and 1. It can be equal to 0, it can be equal to 1, so greater than or so less, so it's probability is greater than or equal to 0, less than or equal to 1. So you could also say uh, all probabilities are between 0 and 1. So I'll accept either of these. The symbols are fine, uh, or this, okay? Um, so you can say no negatives, but that only covers the 0 part. You also have to, make sure that you're not over 1, so you can't have like a probability of 1.05. So, yeah. Okay, so this probability okay, so we'll skip that one. Um, Find the probability that the state has at least four. The phrase at least four, you can read that as four or more, if that helps you. Find the probability that the state has four or more major cities. Okay. Um, I think Michigan has more than four, right? Definitely Detroit, Grand Rapids. I think Lansing has more than 250,000 people, right? So there's definitely three. What's there in Flint? Does Flint have more than 250,000? I mean, after the water crisis? This was in, oh, I guess we'd have to click on the source to figure out when this was, but yeah. Anyway, uh, find the probability. This one, find the probability the state does not have exactly two. That's going to be minus one minus the probability they do have exactly two. Um, Find the expected mean and standard deviation. So calculating standard deviation, we had three methods for calculating mean and standard deviation, and those were on page 254. So let's jump to that. Which method is this one in this case? So method one, so you have raw data. That's a data in a single column. Method two is a frequency distribution. And method three is a discrete probability distribution. So it's definitely method three, yes, discrete probability distribution. They say the discrete probability distribution here shows these numbers. So this one is going to be method three. Okay. So that's going to be stat, calculators, custom. Now, you don't need to click on this in Canvas, the chapter 6 review worksheet, because there's no data set for this. So you're going to have to type those numbers in, right? So right here, chapter 6, there's nothing. No StatCrunch or anything for you. So you're going to go to statcrunch.com, sign in or register, and then sign in. To do method 3, you need to do Stat Calculators Custom. So you're just going to need to go to a blank one. So sign in and this orange button should light up. You'll just click on that and open up a blank one. Okay. Now during the midterm, there is uh, there's a link at the top of the midterm that you'll
Hey,
be able to
Joe.
click on. Oh, go ahead.
Hey, this this has been happening since I was trying to go on StatCrunch for and figure out, and when you had told me I messed up on a worksheet, I was trying to redo it. I was trying to go on StatCrunch and it keeps saying 403 forbidden. Like, what is that?
That's not an issue with StatCrunch. That's going to be an issue with like your firewall or your computer. So, or possibly your internet.
It's
So,
not
um,
it's not the internet because that's on like I'm on this, I'm on Zoom.
oh yeah, yeah. So, um, yeah, we can look at that when we get done tonight. We'll take a look and see if we can figure it out. Because yeah, you're definitely going to want to be able to get on StatCrunch for the midterm. So,
Yeah.
um, yeah.
Okay.
So. As I was saying, so for the midterm, there's going to be a link at the top, and when you click on that link, it'll take you to all of the data sets that you need. It might take you to a waiting screen for a second, but here's the data, the spreadsheet. Here's the link that you would click on for problem number two, and then here's the link that you would click on that's going to take you to all the data sets for StatCrunch. Now, if you're taking it at the testing center, you'll have to, they're going to hand you a paper copy. You're going to have to type that link into your browser, which is easy. It's not a long link. So you'll just type that in and that'll take you to this site where you can get to the data sets that you need. So you don't have to type everything in. So yeah. Uh, yeah, we'll work on troubleshooting any StatCrunch issues that you guys have when we're done with our worksheets tonight. We should have some time. So um, okay, so anyway, for question number one, anyway, you'll just want to type those numbers in. Um, question I here, identify them, or sorry, interpret the mean and the standard deviation in the context of the situation. So that is our give or take script. That's on page 253. Okay. All right, page 409. You work for a large real estate company and are interested in the average monthly cost of utilities in Michigan, which is a combination of electricity, water, internet, natural gas. Construct a probability distribution for your company. Find the expected mean standard deviation. So, exact same thing we were talking about just a second ago. This is just going to be method three again from page 254 because we have a probability distribution and we're going to calculate the average monthly utilities. Okay. Interpret the mean and the standard deviation. Same thing, page 253, give or take script at the bottom. Or I think it's at the top. Is it at the bottom or the top? Yeah, it's at the top. All right. Um, Baccarat is a casino game where players bet on which hand will be higher. Unlike many casino games, it's possible for there to be a tie. The casino payout for a tie bet in eight deck Baccarat is player higher, dealer higher, or tie, negative one, or eight. So I don't know if you've ever played, I've never played Baccarat. So, but apparently you bid on which hand you think is going to be the highest, kind of like blackjack, right? When you play blackjack, you try to get as close to 21 without going over. Um, so usually though with blackjack, if there's a tie, like no money's paid out. But for this game, you are allowed to bet that you're going to tie. So if the player's hand ends up being higher than the dealer, If you bet on the player hand being higher, you win money. But if you bet on there being a tie, well, then you're wrong and you lose your dollar. Uh, if the dealer is higher, then you'll lose a dollar. And then if you bet that they're going to tie and you're right, you get $8. Okay. That's what these are indicating here. Uh, Now this is a probability of 100%, right? If you play the game, one of these three things will happen. So I need to know what the probability of a tie is. So can somebody do 100% minus this? Who's on calculator duty tonight? 1 minus this. And we're going to leave it at 6 decimal places. They have a bunch of decimals here, so let's leave it at 6 decimal places. Should be 0.0 something. 0.0, thank you, Mike. 95156. All right. All right. What's the house edge bet? So calculate the expected profit for the player making a tie bet. You're going to base this expected profit on $1. So if you do a $1 bet, um, then how much money are you expected to make? Okay. Um, so once you've done that, down here, what is the house edge for a tie bet? You're going to take your answer from here, and for question D, you're going to write that as a percent. Okay. All right. Explain why tie bet is not a fair game. All right. Sounds good. Let's move on to the next page. You're going to roll 3 six-sided dice that have weights inside them so that they roll a 6 75% of the time. Okay. So somehow you snuck some dice into this casino. Why is it not appropriate to use a binomial distribution for the variable x in these scenarios? Okay. So to do a probability, when we're talking about a binomial probability experiment, bi means two. There's two outcomes, meaning you succeed or you fail, you win or you lose. Okay. When you roll dice, there's lots of different outcomes that you could get. So you can only use the binomial probability experiment if there's a particular target, like, I need to roll a 10 or higher. Okay. Then in that case, you succeed or you fail when you roll your dice. So there's a couple of different requirements. First of all, random probability experiment is performed a fixed number of times. Okay. So you can't keep rolling forever. Each repetition of the experiment is called a trial. Trials are independent. Okay. That means they don't affect one another. Okay. There's no outside interference. For each trial, there are two disjoint outcomes. You either succeed or fail. Probability of success is consistent for each trial of the experiment. All right, sounds good. So, explain why is it not appropriate to use a binomial distribution for the variable x in these scenarios. Now, if you have weighted dice and you know that they will roll 75% of the time, you can still use binomial probability. Okay. In this case, your success is your p is 0.75, right? And then you roll a bunch of times. So that's not the problem. Okay, let's take a look at question A and let's see what happens. Suppose there's a way to use a magnet so that a person in the room can affect the dice rolls. You're going to toss the dice 10 times. Let X represent tossing a sum of 18. Okay. So the only way to get 18 if you get 6, 6, and 6. Okay. So this is not an appropriate binomial probability experiment. Is it because there's not a fixed number of trials, we don't have two disjoint outcomes, or because the trials are not independent? What do you guys think? Yeah, Rachel's got it. It's because these are not independent. This person with the magnet is an outside influence. Okay. So it's no longer 75% of the time by using this magnet. I mean, the weights are going to make it 75%, but by using this magnet, you can make it closer to 100%. Okay. So, question B, you are going to toss the dice 22 times. Let X represent the sum of the three dice. Why is that not a valid binomial probability experiment? If you're not sure, take a guess. I mean, you got a 1 in 3 shot, right? A 1 in 3 shot that you're right. That's pretty good odds. Hmm. So, do we have a fixed number of trials? You're going to roll the dice 22 times. Yes, we do. You are going to roll 22 times and then you're done. That's fixed. Let X represent the sum of the dice. So, in that case, do we succeed or fail? Well, we don't have two disjoint outcomes. There's lots of different ways these dice could land. You could roll 6, 6, 6, that's 18. You could roll 1, 1, 1, that's 3. You could roll any number between 3 and 18. Okay. So there's lots of different outcomes. The previous one, we said let X represent the tossing a sum of 18. So that means you either did it, you got 18, or you didn't. Okay. Lastly, you want to get a sum of 18. Let X represent the number of tosses it takes to get 18. You can probably guess this one is not a fixed number of trials. So let X represent the number of tosses it takes to get 18. You need a fixed number of trials. So how many times do you need to roll the dice to get 18? Well, I don't know. If you roll the dice once, you might get 18 right away. Or if you roll the dice, you might roll a 5 and then you got to roll again and you roll a 10. You're still not an 18. You roll again. Okay. So not a fixed number of trials. All right. Let's move on to question 5. Determine the indicated probability for a binomial experiment with the given number of trials n and the given probability of success. 4 decimal places. Okay, so on page 256, we talk about binomial probability experiments. And down here, we have the path for the StatCrunch, stat calculators binomial. Okay. And what you're going to put into StatCrunch depends on what you're trying to calculate. So we have a bunch of different rules here. Okay. So this one, we want to find where X is less than 110. Less than would be rule number 2. Okay. So page 256, rule 2. This one is going to be rule 6 because 6 is for between. This one's going to be rule 1. And then this one's going to be at least 105. At least, you can think of that as 105 or more. At least is this one right here, rule 5. So 105 or more would be greater than or equal to 105. Okay. All right. Um, Following are graphs of a binomial distribution where n is 260. Label each graph with its probability of success. The options are p is 0.1, 0.5, or 0.9. Okay. So the best way to answer this one is to take a look at the mean. So when you're looking at a binomial distribution, the mean is the n times p, the number of times you're going to roll the dice or flip the coin or whatever, times the probability of success. So n times p, okay? So this is pretty easy to understand, I think. So like if I flip a coin 10 times, how many heads am I expected to get? If I flip a coin 10 times, how many heads do I expect to get? What's the average number of heads that I should get if I flip a coin 10 times? Five, right? Because, yep, Gabby, you got it. Because n is 10. I'm going to flip the coin 10 times, 10 trials, and my probability is 50-50, right? There's one out of two, 50% chance I land on heads. So 10 times 50% would be 5. Now, am I going to get 5? Sometimes I will, sometimes I won't. If I flip a coin 10 times, it's possible I get 8 heads, or it's possible I get 3 heads. Okay. It's possible I get 5. Okay. So there's lots of different outcomes, but the highest one is going to be the one in the middle. That's going to be 5. Okay. So in other words, what you'll do is you'll just multiply, in this case, your n times your p and figure out where that lands. Okay. All right. Page 411, the CDC has found that 12.3% of US teens have been bullied online. You are going to randomly select 180 US teens. We can assume this qualifies as a binomial experiment. Find the following. So these will be numbers, okay? S, F, and X are all going to be words. Words, words, words. And then mean and standard deviation, those will also be numbers. Now, by the way, mean and standard deviation, we said that there were three methods that we were going to use for calculating standard deviation. That's not quite true. There is actually formulas for the mean and the standard deviation on page 256. So I don't know if you want to count this as method 4, okay? But when you have a binomial probability experiment, you don't need to use one of those more complicated methods because the formula is pretty simple. So page 256 for these, okay? So uh, the mean is n times p, as we talked about a second ago. The standard deviation is n times p times q, and then you take the square root of that, okay? Interpret the mean and standard deviation in the context of the situation, be specific. So this is also a give or take script, but it's the one at the bottom of page 256, okay? So this one right here, out of n random trials, we expect there to be mean successes, give or take sigma successes, okay? Explain what px greater than 30 means in the context of the situation. So anytime we see explain or interpret, we want to write it in English. But there's no script for this. You just use logic. Okay. You don't need to calculate that. You just need to write out what it is. Okay. Um, the probability that exactly 20 have been bullied online. So this is also on page 256. This is you're going to use those same rules and the same StatCrunch stat calculators binomial. Okay. Uh, this last one though, would it be unusual? We say that a event is unusual if the probability that you get is less than 5%. Okay. Find the probability that at least 36 is the same as saying 36 or more. Okay, if that helps you. Okay, I think that's all the hints for tonight. Um, so those hints, so I give the hints because if you're watching this on the recording, you can see how to do some of these, so you're not completely lost. But I also give the hints because when you're studying off of this, if you just have the answer, you can be like, okay, there's the answer, but how did we get that, right? So that's why I give the hints. Let's jump back to page 408.